I think I got a huge smack in the face very quickly when I learned that was not how reality worked. That's a Mike Tyson quote with everyone got a plan until they get punched in the face. That was a real insight then, but I really love that.
Hello, and welcome to a new episode of Cut Talk. My name is Jörg Lunch, and in this podcast we are talking about computer-aided design. We're covering all sorts of fields from software to hardware, actionable technology, and of course, future developments. Today, my guest is Magnus Nilsen, who founded his company Sparkel a few years ago. The company is developing AI tools which are aiming to make life easier in bigger projects, construction projects, especially for the contractors. Hello, Magnus.
Hello, Jörg. Nice to see you.
So
and hear you.
Yeah. So you've told me in our conversation we had before that you started programming already when you grew up in somewhere in the countryside in Norway. Was this already the starting point of your career of founding a company?
Good question. I think in many ways it was not deliberate, of course. It's always funny when you look back. It always looks like a very nice red thread. At least you can you can talk about it in that way. But I think like the truth of every story, it's that it's just exploration, and you happen to find yourself in some place. And for me, programming has always, I'm not sure if it's been an interest in itself. It's always been a tool for me, but I've always been very fascinated about what technology can do, of how it can, basically enhance human capabilities and bring more value with less input. And I think that's why I really started going into it. But like, if you, I'm not so interested in like which language is better and which algorithms are cool and things like that, but just like how input equals as much output as possible, if that makes sense.
Okay, but after you started your education at university, not in software or IT, but you became a structural engineer.
Yes,
right.
That's right. That's right. So I think when it comes to passion, that has always been a passion of mine, architecture and structural engineering, like just buildings. I think these are the biggest physical objects that we build as humans. And it always fascinated me, like, why do they look like this? How do they work in relation to each other? How do you build cities? How do they withstand just gravity, wind, snow, as we have a lot of here in Norway, and these sort of things? Has always like been a massive fascination of mine. These huge structures that we kind of defy the natural laws with.
Okay, and I've seen you worked for a German company after you've finished your education at university. So we could have done the interview in German, right? No, just kidding.
That's as much as I can do.
Tell us a little bit about your career so far, where you started after university and what you were doing.
Yeah, so as mentioned, I studied structural engineering, and with the passion or with the interest and experience, I guess, I had with programming and computers in general, also CAD. From just hobbies before, it felt more natural to focus on that part already in education. So I actually specialized in something called computational mechanics, which is basically using computers to solve structural engineering problems, which I thought was a lot of fun. I think I quite quickly realized there wasn't that many jobs per se that did particularly that. The jobs that I found was actually more like tech companies building software for to help with structural engineering and these sort of things. But those I didn't didn't really know about at that time, because I wanted to work in an engineering company on actual projects. So that's when I started in a German engineering company. I worked mostly in Norway, but the headquarters was in Germany.
So then you told me that's where the first contact you had with the contractor side, and
right.
You were. I think your aim was to speed up CAD processes and the BIM process at this time.
Yeah, exactly. So it started as a traditional structural engineer, and of course, with the background I had with trying to automate stuff, it became more and more using some tools to improve the efficiency there. Kind of went into like the Revit API, since we used Revit at that time, and then learn a bit of Dynamo and things like that to speed up things for people that are familiar with that. But at least it became more and more interesting to see like how we could speed up the CAD processes. And then I became more and more responsible of that part of the company. And then I eventually switched jobs to a company called NTI, which is one of Europe's leading Autodesk resellers and also consultants, where we worked with many different large companies on basically the exactly same thing. We mostly work with designers, engineers, architects, and this is also my background. And this is when you are completely working in the virtual space, right? Here, nothing can go wrong, or whatever can go wrong, it's just digital, and you can just undo and do things like that. But it was the later year, I guess, of the last year I had in NTI. I started working with contractors. And then I think like a trap that many people that have been working in the digital space for too long, I went straight to that trap as well, thinking like, hey, dear contractors, now you can just build your building without any mistakes because all the CAD drawings has been perfectly designed. And I think I got like a huge smack in the face very quickly when I learned that was not how reality worked. I guess it's very that Mike Tyson quote with "Everyone got a plan until they get punched in the face." I guess that was a really real insight then. But I really love that. That really sparked a new passion for me. Like all the challenges that is on site on construction when you're actually building what you had digitally or virtually, making that a reality. That's that translation process basically. Uh, because one of the greatest things that we have in technology here is like 3D printing, right? Because this is probably one of the best one-to-one thing we have between like a virtual design and to some physical object. We're not quite there in construction yet. We're quite far away from that. There are so many tens of thousands of components that needs to be in place with many different companies, many different people, and every project is so incredibly different. So the challenges there was so deeply profound and human and process heavy and people heavy that I found that to be super interesting. So then I worked very closely with contractors for quite a while there to try to see, okay, our initial approach of just like having a perfect CAD does not equal a perfect building. That was at least the biggest takeaway. And I think there are still a lot of people that are a bit stuck, like thinking like as long as the CAD is perfect, then the building will be perfect automatically. But that is obviously not the case. So that idea and that experience is what eventually sparked Sparkel. No pun intended there.
No, that was intended. No, that's where the name came from.
That was actually not.
Sparkle? No,
it could have been. Actually, the thing was that we realized there was a gap between like let's say design and construction, which is solved by 3D printing in manufacturing for smaller components, right? In many ways, but this gap is not solved in construction. How do you rationally, efficiently, and take a design and make it a building? Because basically what we do is print them out, look at them, order based on what is on the design, get them on site in the right place according to the drawing, which works okay, and it's very similar to what we did 2,000 years ago. Of course, there are some developments, but quite similar in spirit. And yeah. So that was the thing. And this gap, why we're called Sparkel, it's written in a like a bit funny way if you're not Norwegian, like Sparkel, EL, not LE, and that word actually means like what's called a plaster gypsum, that thing you have between plaster wallboards to fill the gap, right? So it's actually a pun on filling the gap that in that respect, and also of course that it is a construction material that alludes to that we're doing something in construction.
Okay, tell us a little bit about the founding process. one day you had the idea, okay, I can fill the gap. I have ideas for software, for AI software, which could fill the gap. Well, one day you say, I quit my job, I start my own company, or how did it happen?
Yeah, well, it was a rough process. It was a tough thing. I think, like, to backtrack a bit, even like in my first job, a long time ago, me and some friends actually founded a company that were doing some really interesting stuff. It was actually like a very early like machine learning AI things for soccer or football. Yeah, this is a European podcast, so I'll say football. Uh, then it was able to kind of identify different events in a football game and then create a timeline of what happened in the game. So like in minute 12:45 there was a free kick and things like that, and this team had it and things like that. Oh, it was really cool. And one of the biggest learnings from there was that doing something like this is not a part-time job. That was a big experience, and I think like the biggest takeaway there was that I really want to do something like this sometime, to work on some cool, interesting problems that is meaningful for people, but I have to do it full time. So basically, that was now 10, 11 years ago. So from that day, I basically started saving up so that I could have 1 year without a salary in case I get a good idea sometime. So I was lucky in about 8, 9 years to save up to have about 1 year without a salary, living on ramen, of course, but enough to kind of get by. And then I think like what really sparked what was this experience, as I mentioned, with the contractors. Like there's a real challenge here that basically costs the industry like a huge amount of money, and there's also as you probably heard a lot of time, is waste is a huge problem in construction. It's responsible between 30 and 40% of all material waste in the world, this industry. So, and a lot of this we see is basically coming from a mismatch between what was designed and what was actually built. Because right, if you build exactly what was designed, there is no waste, right? So this 40% is usually coming from that you order a bit too much on purpose because things break, things doesn't go as planned, and it's so expensive to be on site and having like 10, 15 people waiting for new material to arrive. So it's a lot cheaper to just have way too much all the time. So there was a huge problem here that we wanted to solve, and we did work on this quite closely with some construction companies, and that's when we learned a lot. So the initial idea from Sparkle was a way to actually order construction materials from the designs, from the CAD drawings. It was basically very simple in a way that you had a CAD drawing in front of you, and you can click on different things and say like, here the architects have designed or these 10 different windows, and you could basically click on them, and you could send this design and these windows in an easy way to a window supplier, for example, and say like, hey, we want these things. And that is also it does two things. Was the idea then? It should both do the ordering process directly from the design, so it makes sure the design and what is being ordered is more one-to-one, and also keep progress tracking automatically, because when the order is applied, then we know where in the drawing, and we can color that green or something when things are done. And then basically when your entire CAD file is completely green, then you should be good. That was the initial idea, and we got then that's what I started the company of. That's what I quit my job to pursue. And I joined a program called Antler here in Norway, which is a startup incubator for meeting co-founders, basically, and also kind of get your first initial investment. And that went really well. I met a great technical co-founder there that could help me build this thing. I would not say I'm a good programmer at all. I can hack my way through to something that works, but that's not enough to build a company on. So we needed something that was stellar. So yeah, and then we built some simple things like that, and we got actually a few customers very quickly, pilot customers, and then we got an investment from that, from Antler, and yeah, then everything had kind of propelled from there.
And What I found quite interesting is that your customers are not usually, when we talk about CAD, the customer is mainly the architect, the design company, the structural designer, and so on, and not the contractor. The contractor is getting the result out of the CAD, but you're selling your product to the constructors, right?
Yes, that's exactly right. And this was one of my biggest jaw-dropping moments, right? When I go back to that, let's say, that key moment when I worked with contractors for the first time there, when I realized like all of the things that we've done with CAD or a BIM specifically construction basically is not suited for how contractors work. It's not suited at all. It's basically all created from the minds of architects, engineers, and computer scientists. And most of the benefits that you get from CADs there are for them. But at the same time, the idea was like always like, hey, if you do BIM, then construction will be easier, right? But the problem was that there are just basically no good tools for these people to digest these CAD drawings in a sensible way. Of course, what kind of early on, like even 20, 30 years ago, which was very powerful, was just going to 3D, right? Where they were able to get that 3D visualization of the project, because that gives the construction companies or contractors a lot better understanding of what needs to be done. And they could spot mistakes early on. It's easier to coordinate and these sort of things. So that has been kind of one of the main things that has been beneficial for contractors. Another thing is clash detection, which has also been, which is very hard to do in 2D, but kind of, I wouldn't say trivial, but a lot easier to do in 3D, because then you have the geometric objects to compare to each other. And this has also been like a huge value add for contractors. But apart from this, what we've been talking about for at least a decade is this information part that is the I and BIM. The idea there is that you could just extract whatever information you want, because the entire BIM file should contain this information. This is not working at all. Is for construction companies. You can go to any contractor and say like, hey, do you like BIM? And probably 99% of them would say, no, I hate it because it's never correct. It's always inconsistent. It's always missing something. And I think it's been a very common thing to point at the architect or engineer and saying like, hey, they need to do better, or we need better standards or something like this. But the thing is and I was in this camp as well for like at least 7 years. We're like, hey, we need to focus on the design here so that they can actually build something that the contractors want. But when I worked with the contractors, then when I realized that we've been trying to do this for a really, really long time, and we do have the tools to create the perfect CAD drawings quite easily or quite fast. So the problem does not lie there. That was the main realization. The problem is that the contractors don't have the tools to kind of rationally explore when things are not perfect. All the tools that were built was like, hey, this work if the CAD or BIM model is absolutely pristine and perfect. Then you can just query anything and you can connect data from A to B and everything is peachy. But that's just not how the reality is. The contractor is just like a simple example here. What is a lot easier for the architect is using like larger objects, because that means it's quick to change, like a wall that maybe goes through the entire facade, a 30-meter long wall, so to speak. Because then if you want to move it, it's very easy to move it and everything. Yeah, it's a fewer amount of objects and things and dependencies, for example. Yeah, and it's also some good things there about quantities as well. Like if there is a brick wall, it's very easy to just have one object to say, hey, how much brick is in this wall? No, it's this thing. But then you go to the other side of this wall, the interior, then you might be interested in how much paint in a room that is just part of this wall, right? So in those sort of cases, the contractor maybe hey, I want you to divide the wall so that every time it meets like a perpendicular wall or something internally, then it should be divided. And of course, you could do this, but then you have to understand there's quite a big cost of doing that, because that means that every change that you now have to do, the architect now has to move maybe 5 separate walls instead of like one large one. And this is just so that the contractor basically wants to get the question, how much area is within here. And we felt this was like a very silly way to work, where the contractor always had to, hey, I want this, and then go all the way back to the architect, and they have to update something in Revit or ArchiCAD or something, export a new file. They have to upload or send it by mail, and which might be 500 1 GB files. They have to download it, the contractors, upload it again, wait a lot, and then they can get what they want. And of course, they will have a new question just 1 hour later or the next day that are just not exactly how the BIM model is. So the core problem, that how we saw it, is that we will never get to a place where the contractor can always get their questions answered. You just don't have the predictive power beforehand to know all the questions that you might have. Of course, there's a huge, I'm not saying throw away standards. I say that is very important, so you can do the most basic things. But the idea that you will always get like the answer that you need automatically is unrealistic at best. So the main idea there is that the contractor need better tools, so they could just extract what they need. They need a part where, hey, I need the area of this part of the wall, not the entire wall. It's as simple as that.
So, but what you're saying, it's not the problem you're describing cannot be solved by better standard, better software on the CAD side, better educated architects perhaps handling the BIM, creating the perfect BIM model. It's a problem internally.
Yeah.
So it's okay.
Exactly. And that's the main point. And there's an analogy I like to use sometimes. And the core, I don't know if a problem or issue here is that we are different people working in different companies, working in different projects with people within companies that have never worked together before. So it's very complicated like that to have like a consistent way of expecting input output flow. So the analogy I like to use is like if you're an accountant and you are looking at invoices that you get from your suppliers, for example, you of course it would be super easy to automate accounting invoices if you told everyone to send, hey, I want every invoice to be exactly like this. This is the font you're going to use. This is how many pixels from the top left you want to put your address, and you could put the standards. And if everyone used that, that would be great. And you could just automate everything. But I think that they realized quite quickly, like that is a very tough way to work. But at least maybe you could do it very locally for a few of your suppliers. But if you are then suddenly having a supplier in a different country or something, it's very unrealistic to kind of enforce kind of how you would like to have your invoice, right? And no matter how many standards you put or how many, or of course you can train everyone, but it doesn't scale really well. So what they done there, or what they did there, was of course our technology enabled this thing like OCR, optical character recognition, that made it possible to detect text basically on PDF. This was 34 years ago. And then you could basically read the information no matter how the structure was. And you could still get the automation without all that cost of hyper standardization, so to speak. And this is exactly the same that we're doing, I would say.
Yeah. That's where AI comes into the game, right?
Yes.
I'm always impressed when we have this with our bank software, you can just take a photograph out of the banking software of the invoice, and it automatically fills in all the data.
Right,
and the money is transferred. And it's sort of AI, right?
Yeah,
and that's exactly how you're
some machine
working.
Yeah, it's exactly the same approach. So in that case, you are the contractor, right? And like how they are, what they are struggling with today is that they get like this weird receipt that you've had in your pocket for 2 weeks that you barely can read yourself, right? Which is the BIM model in this case. And they are, of course, complaining like, hey, all my tools expect that this receipt is in a perfect way, perfect condition, and that it's using the right font and everything is in the correct place. But every time you, of course, get some receipts that are being curled up in your pocket. And technology like AI can kind of bridge that gap of like, okay, instead of expecting pristine, perfect receipts every single time, with this technology, you can get the automation that you are seeking without having to enforce that pristine input, if that makes sense.
You told me before, and this is probably bad news for the software suppliers, that your tools would probably result in the companies to buy less new software because they don't need to produce a perfect BIM file, but the contractor can work with an imperfect BIM file.
Right. Yeah. I think what I meant in that discussion was a bit different, actually. It was a bit. I think you asked something about the future of AI, and I don't think what you mentioned that. I think it's true in general. I don't think it's true for what we provide, at least not right now. No, it was just like this is just like a pure guess, of course, of me. That would be great to be quoted in 5 years to see how wrong I was. So now, yeah, as I mentioned there, what I think is a possibility in the short term is that what we see is what is expensive for companies is not licenses, it's not technology, it is change. It is getting people to change a system. The licensing cost is almost negligible, at least if you go to larger companies. It's training, support, implementation, just a human part of change. And there are tons of tools that are just better than what they already have. So the rational, maybe a perfect logician, if you if you had like a company full of perfect logician, right? They would probably change their software stack every week because there's a new better one. And if they have zero change of cost, they would just change software, buy the new one. Maybe it's cheaper, maybe it's 2% faster. So that is the rational thing to do, right? But the reason why we don't do that is that there's a huge cost of change itself, and I think that will be true for quite some time still. So I think in like now that AI, even what's called this multimodal AI agents that are able to not only produce text but only understand images, they are able to now control your computer. And what a lot of the reason why you're going into new technology purchases is because of automation, right? You can automate this process in some sort of way. Your ERP system can be automated with accounting, for example, and things like that. But you can either do that with consultancy or you can do that by clicking 10,000 buttons manually, as you probably do today. But when AI can control your computer, it doesn't really matter that it takes 10,000 clicks, as long as it can do it by night or automatic anyway. So the cost of the AI agent, as long as that is low enough, I think that will be far less than the cost of change. So you can basically do exactly what you're doing, but you can still automate a lot of it. I think that will be something that we'll see more and more in the short term, that instead of people purchasing new software for better automation, they would put AI agent on their existing tool stacks. And people can still use what they're familiar with, but you still get the power of automation. That's my guess.
And what would this mean for your company and for your offer? So you're selling the AI agent to the contractors?
Yes. Well, I'm kind of thinking like a bit differently there. I think that these sort of tools will firstly work on the web, browser-based, and that's one of the reasons that we are focusing 100% on browser-based. We are also focusing on. We have now 2 user groups, but now we also need to think about how maybe future AI agents can use our system as easily as possible. So we want to make sure that when this comes, the AI agents are able to use our system in total. So that's more our thinking about it. And I think, as mentioned, cloud, like OpenAI's operator that works on cloud today, using a browser, and we are very lucky there because basically all of our competitors are desktop based. So we have already kind of a head start. So what we hope in the future is that we become kind of the go-to choice of making this automation possible, and it means maybe that we don't have to focus that much on all automation features and maybe more focus on breadth of features so that they can all, because their AI can automate anything anyway. So what will be a roadblock for them would be a missing feature, not like if it's automated or not. So that means, for example, we support 2D, which I think it's really important. It's a contractual important document in construction still. And it means that usually how you do like this takeoff process today is to manually click around and trace like floor plans. And if this can be automated, then if this can be automated in the future, it's already possible to do this in a certain extent, like with a single click today, which is just getting better. But it almost doesn't matter that much if you have like an AI that are able to trace themselves. Of course, it takes a bit longer time, but until it can, in theory, complete an entire takeoff then by doing it the old manual way, and it's still. But it's not manual, it is automated in a weird way, if you know what I mean.
Okay, so very interesting outlook into the future. Magnus, thanks a lot. That's amazing things. I keep my fingers crossed for the success of your company. And thank you.
Why, thanks. It was a pleasure.
Okay, and since the majority of our audience speaks German, I'll now switch for the closing remarks back to German. Ich hoffe, dass Ihnen diese Folge gefallen hat. Ich fand es total spannend. Für Lob und Kritik bin ich natürlich immer offen. Schicken wir doch am besten eine E-Mail an info@cuttalk.de. Wenn Sie selbst mal Gast hier sein wollen, schreiben Sie mir auch gerne oder schlagen jemanden vor, den Sie gerne hier mal als Gast hören würden. Und wenn Sie es noch nicht schon gemacht haben, dann klicken Sie jetzt schnell auf Folgen in Ihrer Podcast-App und dann hören wir uns in der nächsten Folge wieder. Für heute sage ich Tschüss und auf Wiederhören.